All right, let's look at the conservative fields. Right, when we talked about curl, curl is some sort of indicator of rotational flow. So let's say you have a flow in sky blue, which looks like that, and then you are, let's say this is like in the ocean or something, and you were to swim from point A to point B, right? Then you can see that if you take a path like along the flow, it's gonna require less work, right? But if you take a different path, for example, so this is going to be path 1. And if you take a different path, like going completely against the flow, so you're going this way, kind of um, clockwise direction, then you can see that along that path, it's going to require a lot more work since you're swimming against it, right? And or you can go this way, right? So obviously, the work required to swim along these passes are going to be different depending on which path you take. Some are easier, some are much harder, so less work or more work. All right. So if you have a rotational flow, that can be indicated by the curl. So we don't want curl to be non-zero, because if it's non-zero, indicates that there's going to be a rotation. Then you're going to end up having different work for different paths. So path independent. So let's say path independent field is it's called the conservative fields. So here, conservative and this can be indicated by looking at the curl of the force field. So the curl of F should be a zero vector. All right. So here's an example. So let's show that this given force, force is x squared minus y squared comma negative 2xy comma 0. So this, you have a force here, and then let's compute its curl. So it's a curl of this force F is going to be, all right, so we have I, J, K, partial with respect to x, partial with respect to y, partial with respect to z, and we have x squared minus y squared, and negative 2xy and 0. Right? So this comes out to be, alright, so it's 0, partial of 0 is 0, partial of negative 2xy with respect to z is 0, minus, alright, then partial of 0 is 0, partial, there's no z, so it's going to be 0 again, right? The last one is partial of, let's see, negative 2xy with respect to x is negative 2y, minus partial of x squared minus y squared with respect to y would be negative 2x, so it's going to 2y, so positive 2y. Right, so you end up getting 0 vector, right? Which means that, so we say therefore F is conservative. Right. So if you have a conservative field, the work required from the same point A to the destination point B is going to be exactly the same regardless of which path you take, right? And the easy way to detect a conservative field is looking at the curl, and the curl should be a 0 vector. All right, that's it. I hope that this was clear.